was a fantastic overview and so many exciting applications of AI for the environment in a broader sense. So really one question we wonder is how do we scale this up? How do we make the community bigger? And so it's really good to learn from the experts. So this is a good time to introduce our next speaker, Claire Monteleoni, who is a research director at INRIA in Paris and a professor at the University of Colorado in Boulder. And Claire's probably thought about AI for climate science before most people actually knew what this might actually be. And so she started 13 years ago a very, very foundational conference, international conference on climate informatics that brought together a lot of the community working in this space. And today, Claire calls us for action, and she will speak on catalyzing a community on AI for climate change. Over to you.
Thanks. So I'm going to tell a story, and it's a story hopefully relevant for a lot of us here, trying to bring AI to bear on topics for good, about bringing AI to bear on addressing climate change. I like to be inspired by this photo from Aspen, Colorado I took a couple summers ago, where we have nature, wildlife, and human infrastructure all sort of living in harmony. It's a happy picture from Colorado. A not so happy picture from Colorado is the results of this fire that we had a few years ago. And I was actually glad to follow Marcus's motivation of how you can get this sort of event. In our case, the region is used to plentiful snow in fall and winter. It got no snow, so the vegetation was extremely dry. Finally, on New Year's Eve, a snowstorm was going to come in. It was preceded by extremely high winds. So then all it took was a single ignition, and we got basically a firestorm that jumped over our major highways in multiple places on burning embers, and in a day completely leveled these suburban neighborhoods around Boulder and Denver. We also heard a little bit before about other cascading hazards, such as when you have drought followed by wildfire, and this happened in Santa Barbara County, right above a very residential area by the coast, that an intense rainfall happened on the burn scar, producing a debris flow. So a landslide, this is very scary. Boulders coming into your living room, a horrible loss of life and damage to critical infrastructure. So based on these extreme events that we can observe and just general global warming that has been established, for 16 years, I've been pushing the idea that AI can be used to shed light on and address climate change, and working in this field called climate informatics, which was recognized by the World Economic Forum in 2018, when they also put a call to action and said that climate informatics was an important research priority, as we see what benefits AI can have for the Earth. So here's a bit of a timeline. As I was finishing graduate school, I was really excited by the launch of bioinformatics, which was revolutionizing biology along with some advances in genomic data using machine learning algorithms. I was aware of some methods in the past, and I wanted to form a community on climate informatics that would make the same kind of advances in addressing climate change. So I started working with a climate scientist, and also the National Science Foundation in the US was starting to fund research like this, such as $10 million each investments in understanding climate change using data mining and in computational sustainability. So we launched this event, a workshop which eventually turned conference 14 years ago, but 1 year we had to skip due to COVID. We also went to our top conferences in AI and machine learning. And so, for example, in NeurIPS in 2014, we really made a call to action to get people to work on climate change. And we found that hackathons were a really good way to bring individual teams together. So you have students, early career folks, anyone that is good at programming or has taken some machine learning or data science class, together with a domain expert giving us an important data set for a challenge problem. Things really ramped up around 2019. So we took Climate Informatics International. Climate Change AI was also launched, which provides a nice network to get people involved. And NSF started making a major funding, so a $20 million AI institute in trustworthy weather, climate, and coastal oceanography. And we launched a journal, because one of the other things about building a new field is having places where you can publish in a transdisciplinary forum instead of only publishing core AI advances or core climate change domain advances. Now we're seeing much even larger investments from the NSF, and also I've seen it from French governments. There's other investments on addressing climate change using a primarily AI-driven or AI-enabled approach. We've also seen in the past couple years a revolution in AI-driven weather forecasting. So this is a really exciting time to be in the field. We launched the publication site in the very last days of 2020, and we've seen a doubling in submissions every year in environmental data science. So let me summarize what I think of as where AI has had an impact and can have an impact going forward on climate change and environmental sustainability. So those extreme events, those cascading hazards, we ideally needed, AI-informed prediction systems to help save lives and infrastructure, and we needed solutions yesterday. Now, actually, Google and Huawei and other tech companies that have shown the revolution in AI for weather are able to predict the tracks of hurricanes with better forecast skill up to a week in advance versus conventional physics-driven models. Can we take that benefit to things like wildfires? Now, wildfires can spread in multiple directions simultaneously, and also we have to consider interfacing with society anytime we do this climate change adaptation work. I worked for many years in the US, where there's a known legacy of climate injustice, meaning certain communities have been subject to polluters, incinerators, and in the wildfire example, if there's a community that is more vulnerable to lung disease, given a history of environmental injustice, then when we make these warning systems, we should warn those communities, certainly in the track of the fire, but also vulnerable communities that might be farther afield. So what can we do in the near to medium term to mitigate climate change? In the US, we showed that we can use deep sequence learning to better predict at week-ahead lead times when it's going to be sunny. This can reduce costs, reduce uncertainty for grid operators considering incorporating renewable sources. We're also working with EDF in France to try to envision the new wind turbine and where it should be placed, and similarly for the new PV. Winds are changing. That has been established. The patterns have been changing, and the wind turbines of today may not be future-proof. Their operating conditions need to be revisited, and they potentially need to be put in more optimal positions. And then where I actually got into this, because my first work was with the climate modeler, was trying to improve the long-term future projections that we get out of the physics-driven climate models that inform the IPCC, for example, where we showed that while there's a lot of disagreement in future projections, even for a single scenario across IPCC models, we harnessed AI and present-day data to basically adaptively combine the ensemble and robustify our predictions. And then we're now doing this for individual requests such as sea level rise around certain island nations, and et cetera. I just wanted to give you one taste of an idea of what has enabled progress on all three of these areas, and that is this idea of downscaling. So consider this plot from a paper in Science Advances by another group, where on the x-axis is the spatial scale at which the simulation is being run, and the y-axis is the temporal scale. So IPCC is informed by general circulation models, which are in the upper right-hand side of the box. Now, none of us expected that IPCC models were actually simulating individual snowflakes that we have at the bottom left, but you might be surprised that these megastorms and even clouds, which are going to be the key to understanding climate change, do not make it into those general models. So take, for example, the adaptation task asked for by EDF. Tell us future wind patterns and intensities so we can redesign wind turbines and put them in places that will be more future-proof. Well, we actually then need predictions of wind fields at the scale of an individual wind farm, which is not what we're getting out of the global climate models. So this idea of downscaling, taking a geospatial data field at coarse resolution and generating one at fine resolution is one where we have shown that probabilistic generative AI, not trained on text like an LLM, but trained on wind and other meteorological fields, can do so, and it can also do so in a self-supervised way. What do I see as the long-term goalposts? These cascading hazards. We have skill at, say, predicting the track of a hurricane, but what about when these multiple extreme events combine and we know we have outsized societal impacts? Also, climate justice. Any tech intervention should, of course, do no harm, but I would like to aim a lot higher. What can we do to build tech that actually helps undo the legacy of climate injustice? Trigger warning. So in the US, a meteorologist, Jack Sillen, put together this graph, which simply in grayscale plots percentage of Black Americans living in the regions indicated, and the radius of weather radar sensors. So we don't have weather radar everywhere, but we have it in those green circles. Blowing up what's in the legend, he wrote, many majority Black parts of the Southeast USA are relatively far from weather radar sites, meaning that it's hard to gather information or data about storms impacting these areas. So there's the real challenge, even at the level of the data availability, that is highly skewed due to a legacy of climate injustice. First, let's take a pause. AI is not the panacea. We need to call on governments, and we need to implement incentives and economic levers so this sort of thing is fixed and does not happen again. Okay, but I would like to also call for using AI as a driver towards climate data equity. Just like we showed that we can take the future projections of climate and translate them to future projections at local scales that we care about, for example, in energy, that's going from the data, the sparse data future or the no data future and augmenting it with AI trained at the present time. We can also take the benefit of AI from high data regions to low data regions in a variety of ways. Just technically speaking, in the previous example, we could have had a remote sensing product, learn relationships between the remote sensing data and the radar data where we have it, and then apply that trained AI model in some sense as a virtual sensor to create weather radar measurements where we don't have it. Alternatively, you can consider learning high data models in the high data region and then applying them and even fine-tuning them to have them better transfer to the low data regions. My example was from the US, but this is also true when we think about climate change, where the guilty ones are generally industries in the global north, but North America and Europe have really quite a lot of data. And so can we take models trained in low data regions and apply them in high data regions and apply them in low data regions to address climate change? Thank you.